Okay, why don't we get started? So, any questions about anything so far? Anything we did? Any of the assignments? No? Okay, you can ask me later if you want. So, this week we are talking about arrays. And, hey, if you've done lists in Python, arrays in Java are very similar. They're different in some ways, but it's basically just a collection of things. And if you haven't done any programming, I guess this would be your first introduction to a data structure, which is collection of data that you can operate on in some way. So the first thing I'm going to do is I'm just going to open up the chapter 8 summary that I have for you, and let's have a look at it. Okay. All right, so let's just have a look at this real quick. All right, so we have primitive data types, which are the integers, the floats, the doubles, the characters, right? The basic things that are part of the language. And based on these primitive data types, then we can build more complex data structures, if you want to call it, which are going to allow us to do all kinds of fancier things. The first one is, let's say you had a bunch of variables. You had an int, a1, a2, a3, right? If you wanted to declare, 1,000 of these. I don't know why it's doing this. Why are you doing that? All right, so let's say you're trying to declare 1,000 variables. Okay, well, it's very time consuming for you to go in there and type up 1,000 variables. And that's why we're going to use arrays. So what I'm going to do is, let's say I want to declare 3 variables, a1, a2, a3. I'm not going to go all the way as far as 1,000. Instead of doing this, I can do an array. I can say int a and then square brackets. Okay, and in here I can put a number, and now actually that's not how we do it. You have to say a is equal to new int 3. There you go. Okay, so whether I write 3 variables or declare 3 variables this way, or I create an array like this, the result is basically the same thing. We're going to have 3 integer storage places. Okay, so these two are pretty much equivalent or very similar to each other. Okay, so I haven't given these any values yet, but because Java is so nice, what happens is it actually makes these equal to 0 for you automatically. All right. So that's what this is equal to. This right here is another way of saying this is basically I'm going to say a0 is equal to 0, a1 is equal to 0, and a2 is equal to 0. Okay, these are my array elements. So this is my first element. All right, this is my second element. This is my third element. All right, so these are my elements. Okay, the number that you're seeing in here in between the brackets, that is my index. All right, this is my index. Okay, so if this array has 3 elements, the index of the last element is always however many things you have minus 1. Right, so you have 3 things. The last one is going to be 3 minus 1, which is the 2. Okay, So these are the elements, all right? And let's just do it. All right, so this is my element. Okay, so each element in the array is referred to by its index. The first element is always has an index 0, right? First element has index 0. Last element has index of the number of elements minus 1. Okay? So that's basically that is your array. Any questions? Nothing fancy yet. So what else do we want to do with arrays? We can use, there's some built-in methods into the array object which are going to show you how many things are in the array. So I can do system.out.println. There are plus a dot l length plus elements in the array. Okay, and if I run this thing, then you can see there's 3 elements in the array. Okay, using this, I can also create a loop for int I is equal to 0, I is less than a dot length, I plus plus, so that I can show you every element of the array. So system.out.println, and I can show you element, or let's just do it this way, a square brackets plus I plus this equals plus AI. Okay, so if I run this thing now, you're going to see every element of the array like so. Right, so I can have 1,000 things very easily with just a couple of lines of code. I can show you 1,000 things. Okay, I can use this to change my array, right? So this is show the array using a loop. I can also use for int I is equal to 0, I is less than a length, and then I plus plus. I can change the array again, and I can just say AI equals, I don't know, some kind of a number. Let's make it 10. Okay, and then if I show the array again, you're going to see the whole array being changed. Okay, so this is show array, change array. Okay, I run this thing again, and now you can see the array has been changed to a bunch of 10s. Okay, so what is an array? It's a collection of elements, all of which have to be of the same data type, right? So an integer or an array is a collection of items or elements, all of which need to be of the same data type. And this is different than the list in Python, because the list in Python, you can add all kinds of things into it, right? A list can be a list of integers, a list can be a list of doubles and integers. You can have a list of lists if you wanted to in Python. In Java, just like in C++, an array is of one type only, and bless you, that's the only thing that I can fill this array up with. Okay? There's no way for me to be storing doubles inside of an integer array. There's no way for me to be storing string inside of an integer array. Okay? So it's fixed. Another way in which the arrays in Java are different than Python is they're fixed size. Okay, in Python you can start with a list of nothing, and then you can just start adding to that list, and the list expands itself automatically. And same, if you remove an element from the list, it will shrink itself. That's not how arrays in Java work. Okay, so the array size is fixed. Okay, cannot expand or shrink an array. Okay, That's not to say that there isn't lists in Java or that we can't make our own lists, but this is one of the simplest data structures, one of the earliest ones, and there you go. Fixed in size, you cannot change the size of the array, it's always the same data type. Okay? Some things that you should watch out for is if you're trying to give this thing, so this thing has an index of 0, 1, 2, right? If I'm trying to give this thing an array of index 3, right? So let's try to do this. I'm going to say A3 is equal to 100. Okay? What's going to happen is, let's see if it works. You're going to get this error right here. All right, exception in thread main, right? That's where the error was. And what is the error? The error is this right here. Array index out of bound exception. Okay? And it actually tells you what index that gave you that exception. That is the number 3. Okay? So why is that error? Because we have 3 things in here, and since we start numbering them at number 1, there isn't a 4th item or an element which you can refer by index 3, right? So there's no such index. If you have an array of 3 things, there's 0, 1, 2. There's no 3. Okay? So this is the example of, right? This was bad. All right? Below produces error, and the error that you got was this right here. Right? That's the error. So be careful with the indexes. Something like that could happen if you're trying to set up your loop to go to, instead of less than the array length, you can get that error if you make it less than or equal to the array length. Right? And there's your error exception again. Okay. What else? So this is one way. This is one way to declare an array, right? So this here is I am declaring an array of size 3, right? 3 elements. Okay. There's another way for me to declare an array, and I'm going to do that under. So I'm going to go in here, and this is and by the way, so this was me declaring the array, and then here I am initialize the array. Okay? Even though Java will automatically make this stuff equal to 0 for you, right? If you want to be, technically initializing an array, you have to give it your own values. Okay? Unless you want zeros in that array. So the next thing is I'm going to show you how to declare an array and initialize it at the same time. So I'm going to go in there. I'm going to make declare and initialize an array. Okay, so this is the other way. I'll say int b square brackets equals curly brackets, and I'll give it something like 10, 20, 30. Okay, if I do this, I don't have to provide an index. All right, so index here, maybe I should expand this a little, right? So index is not needed, right? Why? Because Java can see how many elements are in the array, right? And create an array of the appropriate size. Okay? So another way to basically declare an array and initialize it at the same time. So this is the first way to do it. The other way to do it is you do it this way. Okay? So let me get this, and I'm going to move it all the way on top. Right here somewhere.
But the difference in one is you're telling me how big it is, but you're not telling me what's in the other, you're telling me what's in and how big it is.
Right, right. So this one is tell the array how big it is without specifying what is in the array, right? And again, technically that is not correct because Java will fill the array with a bunch of zeros automatically for you.
That's true.
So, but let's just say you're not really saying what's going to be in the array. Okay? And this one here is you're declaring the array, you're saying how many things are going to be in the array, and based on that, it figures out that there's going to be 3 of them. Okay? So, any questions about any of this stuff? If you take in C++, it's the same thing. We haven't changed much. Well, there's actually some things that are different, and that is arrays in Java, just like everything in Java, are actually a little bit more user-friendly, because if you remember C++, there's no length in the array, right? You have to do all kinds of, mental gymnastics to figure out how many bytes are in the array, and then figure out what's the data type, and then you divide the thing by the kind of data type that it, however many bytes are in the data type to figure out how many things are in the array. And then if you pass the array inside of a method, then you can't figure out the size of the array inside of the method. You have to pass the size as an argument, right? So not in Java. There's a length part of the array. You can always figure out how long the thing is at any time in any method. Okay? So that's pretty much, these are the basics of an array. Okay, let me jump to the little thing that I have here and see if there's anything else. Yeah, so there's an example in here in the book. All right, explains all this stuff. What's an array, what's an index, right? How do you declare and initialize arrays? The point of these, why would you want to have an array? And some examples of things that we can do with the arrays. All right, so let's start with the basics. Suppose I have an int array C, all right, and this array is equal to like 4, 1. Now let's put the 4 in the middle. I'll put 2, 4, 1, 3. All right, and what we're trying to do is we're trying to find so some of the things. Let's say we start with we want to do sum. Okay, want to find the sum of the array, right? I just make a variable sum, start it at 0, make one of these loops, and I is equal to 0, I is less than the a length, this time it's c length, right? I plus plus, and then I just do sum is equal to sum plus ci. Okay, that's the sum of the array. And if you want to see it, system out println. Okay, sum of array C is plus sum. Right, and if we run this thing, sum of the array C is 10. Right, 2 plus 4 is 6, and then another 4, 10. Okay, so that's one thing I want to be able to do. Another thing that I might want to do is, let's say I want to count how many ones are in the array, right? Let's say I have an array, I have a 1 in there, or 2 ones, right? And I want to count the ones. So I'm going to add curly brackets. Okay, and here I'm going to say, all right, well, if my array ci, right, if any of these elements are equal to 1, right? If any of the array elements are equal to 1, then you can count it. And I don't have a count variable, so let me make one. Count equals 0, count plus plus, right? Also known as count plus equals 1, also known as count is equal to count plus 1. Whichever one you like, I like the shorter one. Okay, so that's me counting how many ones are going to be in the array. So let's put that in there. Okay, there are count, bless you, ones in the array. All right, I run this thing again, and there are 2 ones in the array. Okay, so counting how many things are of a particular kind are in the array, summing all the things that are in the array. Let's do something else. So yeah, average, right? If you want to do the average, system out println, right? The average of the numbers in the array is, and then you do the sum divided by a c dot length, right? However many things are in the array, sum divided by that. Okay. And again, there's like some built-in methods. The average is 2. Is that right? It's an integer, so it cuts off the decimal piece. Okay? Maybe I want to make this a double array. So let me do this. Double. These are all going to be doubles. Okay? So we're going to hopefully get different average. So the average of the number in the array is 2.2. There you go. All right. What else? So summing, this, by the way, is an example of accumulation. Accumulation. That's what the book calls it. All right? Why is it an accumulation? Well, because all these different values add up to the total of the things, and it starts at 0. Okay? You're accumulating all these different values into the variable sum, which starts at sum. All right? So the first time we go through this, right, sum is equal to sum plus c. What's the original value of sum? It's 0. So the first time we go through this, we do 0 plus the first element, which is the C0, right? So we have 0 plus C0, which is 0 plus 2, right? Then the next time we go through the loop, we're going to have sum plus C1, right? And sum is now equal to its old value, which was basically 0 plus 2 for the first one. All right, now we're going to add the second one, so now it's going to be 2 plus the next one, which is the 4, right? Then we go to the next time, right? So when this is all said and done, what's going to happen is you're going to have sum is equal to 2 plus 4 plus 1 plus 1 plus 3, right? That's exactly what happens. Every time you go through the loop, you add one more element to the variable sum. Okay, any questions? Still easy, I hope. Okay, all right, so let's have a look. Sorting, I don't want to do sorting yet. All right, oh, there's also string arrays, right? So you can make an array of strings. It's just an array, right? You can have the user enter the numbers and then make the array elements equal to that. And you can also have the user, this is one of your sample programs, you can have the user enter the value for however many things you want to have in the array, and that's called runtime dimensioning. Okay? In Java, there's not really a huge difference between having a static array and a dynamic array. In C++, there is such a difference. You have to use pointers and all kinds of other fancy, syntax to get this going. In Java, it just works. So, runtime dimensioning an array and just giving the dimension before the program runs, the syntax is the same, right? In one case, you're just going to ask the user for this variable numGrades, right? And then you're going to use that. In the other case, you just put some kind of a number in there before the program starts. Okay? But runtime array dimension is basically you give the dimensions of the array when the program is running. Okay? Another thing is arrays, other than allowing us to sum and search, allow us to sort things. Okay, and why would you want to sort? Well, because searching through a bunch of numbers is much easier if you actually sorted them first. Okay, so if I told you guess a number between 0 and 100, the easiest and quickest way to guess that number is, what number would you pick? Yeah.
59.
All right, close. What you want to do is you want to go half. So I'm guessing a number between 0 and 100. You want to go half of that. Right, and I'll tell you, okay, no, it's lower than that. So you guess 50, now you know that it's between 0 and 50. So your next guess will be what?
25.
25, right? And then if I say, no, it's higher than that, then it goes between 25 and 50. If I say, so you just keep dividing them in halves and halves and halves. So if you have 100 numbers, it will take you no more than 7 guesses to do this, and that's called the binary search. okay? Which is why you want to have the thing sorted, okay? Versus if you were trying to guess the numbers just randomly, you know, maybe I'm guessing a number 99 and you want to start with 0 and you're going to be like, no, try the next one, 1, no, 2, no, 3, no, 4. So you could guess up to 99 times, right? And if we do a whole bunch of these different guesses, the average guess would be somewhere around 50, right? Compared to, you know, no more than 7. So a lot more efficient to do the binary search, which is why we want to sort. So how are we going to sort this thing? Well, let's do it. So what I'm going to do is I'm just going to go in there. I'm going to change this to just 4 numbers. All right. So these 4 numbers, what I'm trying to do is, here's what I want to do. Oh, and by the way, I can find the smallest, right? So finding the smallest will be the same way before I do the sorting, right? Sorting's next. So let's say I want to find the smallest value in the array, right? Want to find smallest value in the array, okay? What would I do? Well, I don't know if you remember this, but you basically, this is the algorithm. You make a variable smallest equal to the first number, okay? And then compare smallest to every other number after the first, and if any other number is smaller, then that is your new smallest. Okay? So that's the idea. What am I saying? I'm saying this. I'm going to make a variable. My variable smallest is going to be equal to this one. Right? So smallest is equal to 2. Okay? And then what I'm going to do is, then I'm going to compare smallest to all these different numbers. So I'm going to check to see, all right, so smallest initially, smallest is equal to 2. Then what I'm going to do is I'm going to compare to see if my next one, right, and the 2 by 2, I mean, which that is my C, what number goes in the middle? 0. Right? Then I have to go and compare smallest to the next one. Right? So I'm going to check to see if my smallest is, or sorry, if my other one, which is the 1, right? So now I'm comparing it to this one, right? Is this one smaller than my smallest? Right? That's the question I'm asking. And if that's true, right, then I'm going to make smallest equal to that number. Okay? And then I'm going to do and repeat, go and repeat this thing for the other ones. So now, you know, I compared it to this one, then I'm going to go to this one, right? So now I'm going to compare it with the 2. And then, by the way, in case you forget your indexes, right? Indexes are 0, 1, 2, 3, right? So now I'm comparing this one to smallest, right? Smallest was 2 initially. Then I compared it to 4. 4 is not, it's not smaller than smallest, so I'm not going to do this. Then I go to the next one. Is 1 less than smallest? Yes, it is. So now smallest is equal to A2, right? Which is the 1, right? So now we pick the 1. Then we're going to go to the next one. A3. Is A3 less than smallest? Is 3 less than 1? No, it isn't. So I'm not going to do this one at all. Okay? No, this is just finding the smallest. Okay, I'll do the bubble sort in a second. Okay, so if I wanted to do this, right, I can do this. I can say, all right, well, smallest is equal to the first number initially, right? So I go in there and I do, okay, make smallest equal to the first number. When is the first number? Well, when I is equal to 0 is the first time we go through the loop, right? So that is when I want smallest to be equal to my AI. Okay? I don't have a smallest yet, so let's make it. Smallest. Okay? So that's me finding the smallest, and then I'll do else, which is, so this one here is true the first time we go through the loop, right? And then so we're making smallest equal to the first number. So make smallest equal to the first number. And then you have an else, which happens automatically for all numbers after the first. Okay, or every other time after the first time we go through the array, this is going to be true because I is equal to 0 only the first time we go through the loop. Okay, so I'm going to say else, and then in there I'm going to do, let's do curly brackets. So if any of these elements, AI, are less than my smallest, then I'm going to make smallest equal to that array element, which is basically what I did here. Okay? Make sense? Let's see if it works. System out println. Alright. The smallest is plus smallest. And whoops. Variable smallest may not have been initialized. Okay, great. Let's do 0. Even though I'm not supposed to, but let's go with this. Array index out of bound exception. Oops, cancel. What am I doing? Oh, I'm doing A. There's no array A, this is array C. Alright? So these are all C's. C. Alright, C. 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 So what's happening is this array C has 4 things in it. My array A had 3 things in it, and I'm running into this array index out of bounds exception, which is the error that I showed you right here, which is basically you don't have such an index. There isn't so many elements, right? C is smaller, C is bigger than A. You're using the loop to go through C, and then you're trying to plug in the index values into A, which is why this thing happened. Okay, and let's try it again. And there you go. Smallest is 1. We found it. Okay? Any questions? Good. All right. So now let me do the bubble sort. Bubble sort, and that is part of this chapter. So how are we going to do the bubble sort? Let's do this. So here's what I want to do the next step. Want to sort the array in ascending order. Ascending order. And what I mean is I want to turn this thing, I want this to turn into 1, 2, 3, 4. Okay? So how do we do this? Well, for me to illustrate this, let's just Google bubble sort real quick. Bubble sort. And look at this pretty picture. Right? So this is what happens. So you have a bunch of numbers, they're in random order. Right? All you got to do is you have to compare 2 numbers to each other. You're going to compare the left to the right. If the left is bigger than the right, you swap their values. Right? And once you're done with that, you go 1 down. You know, then you're comparing 6 to 1. Is 6 bigger? Yes, it is. Swap their values. Move 1 down. Is 6 bigger than 8? Nope. Leave as is. Go to the next one. Is 8 bigger than 7? Swap their values. Then you're going to go and do it again, and then one more time. And when this is done with this first pass, what's going to happen is the 8 is going to end up all the way to the right. Okay? Or the biggest value bubbles up to the top. That's why it's called a bubble sort. Okay? Now, once we move the 8 all the way to the right, we're going to go back all the way to the beginning, and we're going to repeat this process, and then we're going to move the second biggest number all the way to the second place to the right, right? So it's going to go right here next to the 8 where the 4 is. So we're going to grab the 7 and we're going to put it there. Then we're going to go back to the beginning. We'll repeat this one more time. We're going to move the 6, then we're going to move the 5, etc., etc. So that's the bubble sort. And then another way to look at this is, where's that picture? There. All right? So you basically have a bunch of data, a bunch of numbers scattered all over the place, and what you're trying to do is you're sorting them from top to bottom, right? You're starting with the biggest one, keep sorting them and sorting them and sorting them this way. Okay? You can do it this way. You can also do it the other way. You can sort it from the bottom to the top, right? But since we're sorting it in ascending order, there you go. So how am I going to do this? So just like I did with this here, right? This is to find the smallest, right? Let's say this here was my, so the above was my, you know, I don't know want to call it algorithm, but let's call it that. So algorithm to find smallest, right? This stuff on top, okay? If I can spell it. All right. So now what I'm going to do is I'm going to have to come up with some kind of an algorithm to find to sort the array. All right. And what was an algorithm again? Set of instructions, set of steps for me to follow so that I can solve some kind of a problem, right? A recipe is an example of an algorithm, right? A sequence of steps you have to do to get something done. Okay, you don't really need to have formulas in my algorithm, but if I need to, I can throw them in there. So let's do this. What I'm going to do is, looking at that picture that I had, what I have to do is I have to compare every two numbers next to each other, right? And so I'm going to compare these two, then I'm going to compare these two, then I'm going to compare these two, right? So let's just write it out just the same way that I did right here. So I'm going to do this. I'm going to say, okay, well, first, and again, these are, remember the index says 0, 1, 2, 3. So I will do it right here. So first I have to do, oh, I got to show you how to swap. I haven't shown you the swap business yet. Okay. So first of all, let's say, how do you swap? Let's do the swap right here. You have an int x is equal to 1, and you have y, which is equal to 2. And I'm trying to swap the values so that x is equal to 2 and y is equal to 1. How do I do this? Make a third variable, right? So I make a third variable, temp. Okay, and by the way, if I just try to do this without the temp, right, I'll do this. Let's say if I say x is equal to y, what happens here? I have x is equal to 2, and I also have y is equal to 2, and I lost the 1. 1's gone. If I try to do y is equal to x, and I don't do this first, right? If I do this, then my y is equal to 1, and my x is equal to 1. So I lost the 1. So before I do either one of these, what I want to do is I want to store the value that I'm going to lose. So in this case right here, I lost the 1, right? So before I do this one, what I'm going to do is I'm going to say, okay, well, temp is equal to x, right? So now temp is equal to my 1. Then I do x is equal to y, so now they're both equal to 2. And then the next thing I'm going to do is I'm going to say y is equal to temp. Okay, so now my y is equal to 1, my x is equal to 2, which is what I wanted. Okay, I swapped their values. Okay, so that's one way. I could also do it with the other variable, right? If I don't want to do it this way, I have to say temp is equal to y, right? And all that other good stuff. So this is an example of how you swap values. All right, example of swapping values. And we're going to take advantage of this to do this stuff. So what we're going to do is we're going to compare this one to this one. All right, let me start this thing with, yeah, I'll leave it there. Okay, so first I do if my A 0, and I keep calling it A, it's actually C. C0 is bigger than my C1, right? If that is true, what I'm going to do is I'm going to say temp is equal to C0, right? C0 is equal to C1, right? And then C1 is equal to my temp, which is exactly what I did with this example right here, except now I'm using arrays. Okay? So when we're looking at the first one, is this bigger than this one? Is this going to happen? Is this swap going to happen? No, because 2 is not greater than 4. Okay, so that was the first two. Now I got to go and I got to compare the next two. So what I'm going to do is I'm just going to copy this stuff. paste it, and I'm going to change the 1 to 2. All right, and just to remind you, all right, these are the indexes. Index 0, 1, 2, 3, right? So I already compared the 0 and the 1. Now I'm going to doing the 1 and the 2. So the 1 changes to 2, and the 0 changes to 1. All right. So now I'm comparing the next two. I'm comparing 4 to 1. So okay, now this time is it going to happen? Yes, right? So the first time we do this, right? At the end of this, it's that, right? Then when we're done with this, then the 4 and the 1 should swap places. So the 4 should go there, right? And then I can grab this thing and do it one more time. And now I'm going to compare these two. Okay, so now I'm comparing index 2 and 3. So I'm going to change the 2 to 3. 3, 3, the 1 becomes a 2, 2, 2, right? So now we're comparing, is this bigger than this one? Is that going to happen? Yes. So now the 4 moves all the way to the end. Okay? So when it's all said and done, that's what should happen. Okay. So now the next thing that I want to do is, since this is 4 numbers, and I don't know how many numbers I'm going to have. I might have 2 numbers. I might have 15 numbers. I might have 1,000 numbers. I might have 1,000,000 numbers, right? I might have a whole lot of, just different kinds of numbers in there. So what I'm going to do is I'm going to call this my I. Let's say I'm going to call this I, right? This piece right here, that's the I. Okay, this is the I. And I'm going to call this here I also. Okay, so what I want to do is I want to come up with some kind of a generalization for the I. Where does it start? Where does it end? So that I can work with any kind of number of numbers in there. So what's the initial value of I? What is it equal to here? 0. Okay? And then here I is equal to 1. Right? And then here I is equal to 2. Okay. But I want to express this 2 here in terms of how many things are in the array. So this here 2 is actually equal to my c dot length. And what was c dot length? How many things are in the array? 4, right? So this here, right, is equal to 2, or it's equal to c dot length minus 2, right? Does that make sense? So that's how I want to set up. So this is my final value of I. This one here is my initial value of I. Okay?
I just have one question.
What's up?
At the bottom of it, it says you have the array as 2, 1, 3, 4.
Yeah.
Have you finished it? Because it doesn't need to be 1, 2, 3, 4, don't you?
I haven't sorted it all the way.
Oh, okay.
So yeah, all we did here is, so right now what we're doing is we're moving the biggest number to the right. Right? That's all we're doing right now. So all we did was we grabbed the biggest one and we moved it all the way to the end. Then we're going to repeat this over and over and over again. Question?
C dot length equals 2, the final value of I, isn't that?
C dot length,
minus 2.
yeah, C dot length minus 2. That's what I meant. Okay? Thanks. Okay? So now I make up some kind of a loop, and that's why I like to do these. I like to write them out so that I can visualize what happens, and then I can, create the general thing. So what I'm going to do is to simulate this thing on top, I'm just going to make a loop for int I is equal to, where does it start? What's the initial value?
0.
Okay, I is less than or equal to, well, let's just go with less than. What do we say? C dot length. Okay, I'll take your word for it. I plus plus. Before I even try to do anything, what I'm going to do is I'm just going to show myself the values of I. Did I get the I that I want? System out println I equals plus I. Remember, the values for I that I want are 0, 1, 2. Is this going to give me that? I don't know. Let's try. Oh, it's right here. So I got I is equal to 0, 1, 2, 3. Is that what I want? No, because this thing is supposed to go to 2 only. So how do I change my loop?
C dot length -1.
Minus 1. Okay, let me test it again. Did I get what I want? 0, 1, 2? Yes. Okay, we're good. So now the next thing that I'm going to do is I'm just going to copy these here. I'm just going to start with that first one. Right here. Alright, and I'm going to take out this piece. Throw this in here. And maybe I should throw in some curly brackets. I should have done that. Okay. And what are you complaining about? C. Int. Well, anyway, here's what we're gonna do. We're going to change the 0 to I, like we said. Right? This is I. This is I. Still doesn't like it. Oh, temp is an int. So let me make temp here. I'm going to make it double. Alright, the reason it's complaining is because let's make these all doubles. Okay, the reason why I was complaining right here was because I'm saying temp is equal to C, but the C is an array of doubles, and it's warning me that I might lose something if I'm trying to force a double into an integer. Okay, so but that's fixed. So the next thing that I'm going to do is I'm replacing every 0 with an I. And what do we want to replace this number? I plus 1, right? So if this was 0, right, and this is 1, if I call this an I, then I'm going to call this I plus 1, right? So all the 1s go to I plus 1, and this one is also an I plus 1. Okay? So now when this is all said and done, hopefully I can just show the array, see what it looks like. So I'm going to do this. I'm going to say for int, let's call it k is equal to 0. K is less than c dot length, k plus plus, and then I'm going to do a system out print ln, and I'm going to show you. Let's do it this way. So I'm going to do this one. And array equals curly brackets. And I'm going to do, damn it, not there. I'm going to do int k is right here. Okay, I'm going to make this k length minus 1. I'm going to show these all on the same line. Print. I'm going to show all the values ci. Or it's ck. Right? That's my variable k. Okay. And then the next thing that I'm going to do. Oh, and I got to put a little comma plus comma after. And then I'm going to put another system out print line right here. This one's going to be print ln, and instead of comma, I'm going to put this. Okay. So what I'm trying to do is I'm going to show basically array equals curly bracket. That's this. Then I'm going to show you this one, and this one, followed by comma, and then the last one, which is this one right here, I'm going to show you the value of that and then a curly bracket after it. Okay, so let's see if it works. So at some point, let's make it a capital array so it stands out. I run this thing, and I should have made this print. Here's my array. 2, 1, 3, 4, right? So I moved the 4 all the way to the right. Convinced? Okay. Yeah, let's see what else do I want to do. So this is, let's put a little comment here. So this is showing the array. Okay. What's up? I did the int k here because this piece right here is outside of my loop. If I did an int k here, if I did it that way, look what happens. It tells me that it cannot, it does not recognize this variable k. Why is that?
Because it's in the condition, so they,
Because it's outside of the
it's
loop,
outside there.
right? If I don't have curly brackets, if I have this thing the way it is, then it's basically the same as doing this, right? So I have put the curly brackets around this, that and whatever I have outside is, this is now outside of the loop. This is a local variable which belongs to the loop only. I can't use it outside of the loop unless I declare it outside the loop, which is why I declare it.
To show it. Basically, I'm use k just to show.
I'm declaring k here so that I can show it outside of the loop,
Okay.
right? And then the loop, remember how the loop will go, increase one more time before, until, so basically it will not really stop at length minus 2, which is what I'm saying here. So remember, if I have k is less than 4, k is going to go 0, 1, 2, 3, right? But if I tell it minus 1, it will go to 2, and then I show the final 3 at the end. Okay? So that's the monkey business I'm doing here. So I'll run it again. Here's my array. I moved it all the way to the end. Okay? So, and again, this was my loop to move the biggest all the way to the right. Okay? Now that I have, and let me copy it. All right, so when this is done, when this is all said and done, we're ending up with this array here. Okay? So the next thing that I want to do is, I want to move, I kind of put the 3 in the wrong place. What's up?
If it's sorting it, then the 1 would be the first one, wouldn't it?
Yeah, eventually the 1 should go at the front.
But right now it is.
No.
Right now it's just showing.
Right now we have only moved the biggest number to the right, so we haven't sorted the thing yet. Okay, so the purpose of this loop is just to move the biggest number to the right. Okay, and then maybe I should change this around so that, let me change this to something different. All right, I'm not going to do 2, 4, 1, 2, 3. All right, I'll do it this way. I'll say 4, 3, 2, 1. Right, that way it's really messed up. So if I run it again, now you're going to see that, damn it, still the 3 is there.
Because it's in, you got a comment. It's in
Well,
comments.
duh, I'm changing the comments. Let's do this. So I want to do 4, 3, 2, 1, right? Run again, and there you go. The 3 is at the front. Because I want a really messed up scenario so that, you can see how it changes. So at the end of this loop, I got this. Alright, so now the next step is, how do I move the 3 at this spot? What do I do for that?
I think in the condition up top, if you just add 1 to the condition, would it more, or would it?
Well, let's do this. How about I just grab this whole loop right here. Alright, I'm going to copy it. Copy. Paste it here. Let me fix my indentation. Okay, so I'll do it again. And then when I do this again, let's see what happens to the array. Now the 3 moved here. Alright, so at the end of this loop now, the 3 moved. Alright, and if I wanted to move the next one, if I wanted to move the 2 one at this spot, then I would just grab this loop again, copy it. Alright, paste that in there. Let me fix my indentation again. Alright, and now when I show the array, you're going to see that, oh wait, now the array is sorted. 1, 2, 3, 4. Okay, so now this thing is sorted. Okay, so, and the reason I did this was similar to the reason that I did it here. Right, it's just easier for me to visualize what happens. Right, okay, so now I know that I have to do, if I have 4 numbers, I had to do this thing here, c length minus 1 time, right? Which is 3 times, and guess what? That's the same number of times that I had to repeat this loop, right? So what I'm going to do now is I'm going to put a comment around this whole thing here. Okay, and then what I'm going to do is I'm just going to grab one of these here. Okay, so this is doing the below to c how many times we need to repeat the loop. Just like here, I needed to see how many times I need to do these ifs. Okay? So I copy one of these loops, paste it in there, and then what I'm going to do is I'm going to make another loop. I'm going to make it a for int, call it j is equal to 0. J is less than my c dot length minus 1 again, j plus plus, and then I can do the curly brackets even though I really don't have to. Here's my curly brackets for this, right? And again, this is the loop that moves, loop to move biggest number to the right, right? And this loop is loop to sort the whole array, right? And the combination of these two is known as bubble sort. Make sense? Okay, and this is actually we can make this more efficient because once I move my biggest number all the way to the right, which is the purpose of this loop, I no longer have to go all the way to the right because I already moved the biggest number all the way to the right. So if I really wanted to, I can improve the efficiency of this and make this happen one less time as this is increasing. So what I can really do is I can say, okay, well this is minus 1. Well actually, first of all, let's not take my word for it. Let's run this, right? And see if I get the same result as I did when I copy pasted this a bunch of times, right? So I'm going to run it, and there you go. Now it's a sorted array. So what I'm saying though is that because remember when we looked at that picture here, once we have the number moved all the way to the right, right? Once the 8 goes all the way to the right, we no longer have to go and compare the last 2 digits to each other, right? Because the 8's already at the end. So you don't need to go all the way to the end. You need to go one less than that the next time. So how are we going to do that? Well, I can say, well, instead of minus 1 here, it's going to be minus 1 plus j, right? J is 0 initially, so I don't take anything initially. Second time, j becomes 1, so it's going to happen one less time. And then if it's all good, I still have a sorted array, but except this time I made it a little bit more efficient. Make sense? Okay, but let's not do that. So for me, it's more important that you understand how it works. So I'm going to take this out for a second, or not for a second. I'm taking this out now that I showed you how to make it more efficient, and we'll leave it to the original, which is what it was. And that's your bubble sort. Any questions? Okay, so what else do I want to tell you? So the next thing that I want to do is let's look at this here. What else do I want to tell you? So that was the bubble sort. I showed you example of accumulation, a bunch of arrays, string arrays, creating an array and giving it the size of this array during the time when the program is running. That's the runtime dimensioning. Initialization of different arrays, right? There you go, same thing. Deep array versus shallow array copy. So the deep array, what happens with a deep array? So first of all, this is an example of a shallow array copy. Okay, so you're saying one array is equal to some other array. And this is what is basically arrays are objects. Okay, if you make one object equal to another object, the consequence of that is that anytime you change one of them, you're changing both. So whether I change array 1 or I change array 2, I'm changing the value of the array where that both of these are pointing to. So think of both of these objects as pointing to some place in memory where the values of the array are stored. So they're both pointers to the same place in memory. If I change one, I change both of them. Okay, this is different than the deep copy, and there is a system.array copy which allows you to get the contents of one array and one by one pretty much store them into an entirely different new array. What's the difference between this one now and the other one? Well, if you change one of the arrays, you don't change the other one. Okay, so deep copy makes an entirely different array, changing one does not change the other. Shallow copy makes both of the array variables point to the same array. Changing one changes both. Okay, so now you know. Deep and shallow copy. Searching and sorting. So the Java has its own sorting and searching algorithms, which are actually the sorting algorithm in Java is going to be a lot better than the one I showed you. A lot quicker, a lot more efficient. And the next thing that I want to show you is using arrays as arguments. Okay, so remember in here how I kept showing the array, right? Well, I showed it one time. So here's what I want to do. I want to put this stuff inside of a function, inside of a method. Okay, so what I'm going to do is I'm going to grab this, I'm going to copy it, I'm going to go all the way to the top, and I'm going to make a method, public static void show array. All right, and inside this show array, I'm going to do this stuff. Okay, and now it's complaining because it doesn't know what C is. Why it doesn't know what C is? Well, because variable C is declared inside of my main. Right, this is my main, and this method is not in the main, so this method cannot see the variable which is declared inside of the main. So what am I going to do? I'm going to create an argument for I'm going to create a parameter for this array. So this was C was double, yeah. So I do double, and let's call it C square brackets. And now it knows what C is, here, okay? Then, whenever I had that show thing, right, this piece right here, I'm going to take this out, and I'm going to do C dot, I'm going to do show array, and then I'm going to put C in it. Just like that. Notice that I'm not putting the square brackets, I'm not putting a number, right? I'm just putting the variable name for the array itself. And the consequence of this is that I'm going to send the entire array into the function, into the method. Okay? Is it going to show me the same thing? I don't know. Let's test it. So hopefully I get to see this thing right where it was. Run it. Yeah, there you go. Perfect. Okay, another thing. Let's say I wanted to put this inside of a method. Also, I want to put the bubble sort inside of a method. Okay? And by the way, just to remind you something, right? So let's say I have a public static void bubble sort. Right? Just like that. And let's say in it I have an int a1, just like that. Just so I can show you something. Okay? And then in here I'm going to say a1 is equal to 1,000. Okay? And then what I'm going to do is I'm going to call it right here, just so that I can illustrate this thing that I'm trying to show you. Okay? So I'm going to say, okay, bubble sort, and I'm going to send a1, and then I'm going to ask you this question: system out println a1 equals a1, and so before and after. And you tell me, what do you think the value of a1 is going to be?
It's gonna be zero all the way through.
So, okay, so you're saying this one here is going to be 0. A1 is equal to 0. What about this one?
They'll all be zeros,
Why is that?
because that's what the values are that are in it.
But what about this one here? I'm changing it.
Well, I guess it can be a counter. But isn't it the value that's in it that's given to a that's shown instead of the index?
So
Instead of the index?
well, this is not an, yeah, we're showing the value, 0. Right? So let's say, okay, let's say this is 99. This will be 99. And you're saying this one is going to be what, 99 or 1,000? 1,000? Huh? 99? Your original guess was right. It's 99. Why? Because this here is a local variable. This variable a1 is a completely different animal than this variable a1. They're called the same, but they're actually different variables. So me changing this one here has no effect on this one here. Okay? So if I run this, you will see that it's 99 before and after, right? Even though I'm trying to change it here. Okay. This is not what happens to an array though. Okay, when we're sending an array in Java, it automatically sends a pointer to the original array. It's actually passed by reference. Okay, so even though this does not change regular variables, now what I'm going to do is I'm going to call this well, let's call it x. Right? So this is going to be an x. So I'm sending the whole array. Right? I'm not going to do this. Let me take this out. All right? And change this back to what it was. Okay, so now what I'm going to do is I'm going to grab my bubble sort, which was right here. All right, I'm going to copy it. I'm going to throw it right in here. Okay, and I'm going to have to change this thing to x. Whoops, yeah, x. All right, so wherever I see a C, I got to do an x, 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 x here, here, here. Oh, and this is a double. Let's keep it straight. X, x, x. It doesn't know what temp is, so let me declare a temp here. I'll do it right in there. Save space, double temp. Okay, so now it's fixed. So now what I'm going to do is, instead of doing the bubble sort right here, I'm going to comment this out, and I'm going to do what was the name of the function? Bubble sort. Okay. Bubble sort, and I'm sending over the array C just like that. Bam. If I can spell it. Bubble there. Okay. So now I'm sending the whole array into the method. Unlike a variable, we're actually passing a reference to the original array. So changing the array here, will change the array declared in the main. Okay, so array x points to if you want to call it this, is a pointer to array C in the main. Okay, or you can think of this as the shallow copy. Right? You basically have two arrays pointing to the same memory location, changing one changes the other. Right? So now when I run this thing, you should see that it's still sorted, hopefully. And yes, it is. Okay? So now you know how you can put arrays as parameters and how to send an array argument. Okay? If you're sending an array, if you're doing this, let's say I want to send an individual array element. That will be the same as if you're sending an array a variable. That was that early example that I had with the A1, right? So if I send an individual array element, first of all, this function is not going to work for a single array element because it's expecting a whole array, not just a number. But if I was to create a function which takes an array element, if I was to change this element in my method or function, it's not going to change the original array. Okay, it's the same thing as sending a single variable. You know, it's not going to change the variable, the argument that you're sending, right? So this here is array as argument, array argument. Okay, and you can read the book about some more information about arrays and arguments and all that good stuff with more detail. Okay, so there's one more thing I want to tell you because I gotta do something else with you today. All right, so the last thing is two-dimensional arrays. Let's see if I have it in there somewhere. Array lists. Oh, there's also array lists. What are array lists? It's an array that it can expand and contract in size. Okay, look through the book. There's examples of array lists, but it pretty much works similarly to an array, except that it starts with nothing and then you can expand it with as many elements as you need. Okay, now two-dimensional arrays. And I'm just going to copy this thing. All right. So let's say right here, all the way at the bottom, two-dimensional array. There you go. Okay, so how does this work? And by the way, you can have 3-dimensional arrays, you can have 4-dimensional arrays, right? There's as many dimensions as you want, right? Okay, if you have like some kind of a matrix multiplication and stuff like that, this actually works really nice. So how does this work? Let's say I wanted to show this value. How would I show it? I do system out println, and I'm going to say val square bracket equals, whoops, damn it, here plus what numbers do I put in the square brackets? I want to show the 8. 0 sounds good to me. So I'm going to put a 0 in here, a 0 in here, 0, 0. All right, run it. There's the 8. Okay, I want to show this one. I want to show the 52. How am I going to show it? So this is the 8. All right. So now what I want to do is I want to show the 52. How do I change these numbers to? 0, 3. All right. Oops. 0, 3, 0, 3. Right. And by the way, like this is, I guess, this is my I and this is my J. Oh, that's bad. Hold on. There you go. All right. So you said this. Let's see if we get the 52. That's a 52, right? So this is my I. I is the actual column, right? I is my actually row. I is the row, right? And then J are my columns, right? So it's like you have a J in there, J, 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 and these are the I's. Okay, so J is the column and I is the row. Okay, so let's say I want to get this one. What do I get? How do I get the 2? All right, I want to show the 2. What do I do? 0, 1, 2, 0, 1, 2. So it should be 2, 2. 2 and a 2. Okay? And you need to know this because your final project will ask you to do a 2-dimensional array with buttons. Okay? Don't worry, it's not hard. I'll help you with it. So that's it. That's all I have to tell you about arrays. Any questions? Going once, going twice. Don't leave. I have something for you. I got to do this for every one of my classes. Who wants to be my volunteer? Okay, thanks. So, you know the drill. I'll leave the room. Put in a good word for me. All that good stuff.
You're in the, at the middle of the semester you do this? Like
No, that's what they give to me. Yeah.
Oh, really?
Yeah, yeah. They don't do this in the summer.
Oh, okay.
But yeah. And I'll distribute this stuff for the online students too. And damn, wait, did I record this? Oh yeah, there we go. Stop recording.